Alright, here we are, day 2 of Maclaurin and Taylor series. Let's build a Maclaurin, build a Taylor, talk a little bit about the difference, and then we'll jump into some AP questions regarding this topic. Alright, so let's expand looks like a Maclaurin series here, since I see Maclaurin here. Let's take f of x, which is natural log of x plus 1, find its derivative, and then the two derivatives following that. That would be 1 over x plus 1, which if you want to think of it as x plus 1 to the negative 1, that might help you to do the derivatives. I could use that then. That would make this negative x plus 1 to the negative 2, which of course is negative 1 over x plus 1 squared. Alright, and then the following one would be positive 2 x plus 1 to the negative 3. So that would be 2 over x plus 1 to the third. Alright, so let's plug in 0. Looks like I'd get 0 here because the natural log of 1 is 0. If I plug in 0, I get 1 here. If I plug in 0, I get negative 1 here. And if I plug in 0, I get 2. So that's going to allow me to build my Maclaurin series. It looks like I'll have a third degree polynomial. Alright, and it will be equal to 0 plus 1 times x minus 1 times x squared over 2 factorial plus 2 times x cubed over 3 factorial. Let's clean that up. So that means the natural log of x plus 1 is approximately equal to x minus x squared over 2 plus x cubed over 3. And you can imagine, it looks pattern-wise here like this would end up being an alternating series. That would probably be x to the 4th over 4 and on down the line. Now, just one thing here. This series here is only applicable on the interval of convergence of this function. Okay, and I believe the interval of convergence on this function was from negative 1 to 1. Alright, so it's something to be aware of. Just be careful with regards to your work with the factorials. That's probably the biggest hang up for most. Alright, let's do a Taylor series. Now this is a Taylor series. It's just a Taylor series around 0. But we call it a Maclaurin series because it's unique in that way. So a Taylor series that's not around 0. Let's use the following. So as you see, this is different than a Maclaurin series because we'll take f of a instead of f of 0, and f prime of a, and f double prime of a, and f triple prime of a, etc. down the line. And we take x minus a instead of just x. So let's build this thing. Again, we got the same values here. So this would be 1 over, this is the same function, 1 over 1 plus x. This would be negative 1 over 1 plus x squared. And this would be a positive 2 over 1 plus x cubed. Alright, so if I plug in an e minus 1, alright, I want you to imagine, alright, I take the natural log of e minus 1 plus 1. Okay, that's going to be the natural log of e. So that'll equal 1. Okay, so our constant will be 1. F prime, if I put in an e minus 1, the 1 here and the negative 1 are going to cancel. I'll get 1 over e. Okay, and the next one, I'll get negative 1 over e squared. And the next one, I'll get 2 over e cubed. So now I can build my Taylor polynomial. Okay, so the natural log of x plus 1 centered around e minus 1, right, will be 1 plus 1 over e, right, that's f prime of a times x minus a. Alright, so times x, now let's think about this, x minus e minus 1. That'll be the same as x plus 1 minus e. So let's write it like that, x plus 1 minus e. Okay, minus 1 over e squared. That will be, again, x plus 1 minus e, this time to the second power, and don't forget to divide by 2 factorial. Okay, and then our third term will be plus 2 over e, x plus 1 minus e cubed over 3 factorial. So let's clean this thing up. So the natural log of x plus 1 will be 1 plus x plus 1 minus e over e minus x plus 1 minus e squared over 2e plus, what's going to happen here is 2 will cancel with the 2 and 3 times 2 times 1. So I'll get x plus 1 minus e cubed over 3e. And you can see that pattern start to take hold here. Alright, now I want to talk about what happened to this interval of convergence. What did we do? Alright, normally this converged between -1 and 1. But what did we do? We shifted it over e minus 1 units. So I'm going to add e minus 1. Okay, I'm going to add e minus 1. So now the center is no longer at 0. The center we're going to figure out here in just a second. Okay, so I got e minus 2 as the left end of my interval. And I got e as the right end of my interval. So the center of my interval of convergence would be whatever that is, 2e minus 2 over 2, right? Which would be e minus 1. Oh, there you go. Look at that. Interesting. Did you learn something? That's where it's centered at. Alright, so if I wanted to approximate values of the natural log in this range of values, I would be okay to do so because it's convergent in that interval. All right, now that's a funky example, all right, but it's it kind of clears up some of the mystery of Taylor polynomials. All right, folks, let's move on and do one more here. All right, I want to look at real quick how awesome the Taylor polynomial for f of x equals e to the x is. What's cool is that we know this about, let's go out to the, I don't know, let's go third degree. What we know about e to the x is that its derivative is itself. So we get e to the x all the way down, which is great. So if I want to build a Maclaurin series about 0, it's pretty easy. What is f of 0? It's going to be 1, and the rest of these are going to be 1 as well. Alright. In a moment, we're going to do f of natural log of 2. E to the natural log of 2, alright, natural log of 2 is just going to be equal to 2. So each of these will be 2. Now they'll be centered at a different location, but at least they'll all be 2. So let's go ahead and cruise through this one, build these two polynomials. Let's see what happens. So e to the x as a Maclaurin series will be approximately 1 plus 1x plus 1x squared over 2 factorial plus 1x cubed over 3 factorial. It's awesome. Now e to the x is convergent everywhere. It doesn't have a radius of convergence, so we could use, the further out we go, the better the estimate. Okay, but we could use this for any value of x, right? And if we centered this Maclaurin, or this Taylor series, around natural log of 2, then e to the x would be approximately 2 plus 2 times x minus the natural log of 2 plus 2 times x minus the natural log of 2 squared over 2 factorial plus 2 times x minus the natural log of 2 cubed over 3 factorial. We could clean that up a tad bit. E to the x would be 2 plus 2 times x minus natural log of 2 plus x minus the natural log of 2 squared, right? These two would cancel, plus x minus the natural log of 2 cubed over 3. Pretty cool stuff. Alright, let's do an AP problem. Alright, I want to look at number 20 here real quick. This to me looks just like e to the x. Watch this. Remember how e to the x was 1 plus x squared over 2 factorial plus x cubed over 3 factorial on down the line. So I would have x to the nth power over n factorial. What is x? Well, x is the natural log of 2. Therefore, this is really just e to the natural log of 2. And what would that come out to be? Come out to be 2. Sweet, too easy. Alright, let's move on and look at a free response question. Alright, so check this one out. It says a function f has derivatives of all orders at x equals 0. That right there is going to tell you that it's a Maclaurin series. It says Taylor right here. It says Taylor, but this is a Maclaurin series, okay? So it is known that f of 0 is negative 4, and p, the polynomial, first degree polynomial, with 1/2 plugged in is negative 3. So show that f prime of 0 is 2. Okay, so recall that a polynomial first degree will be f of 0 plus f prime of 0 times x. So if we want to know, if we want to figure out what f prime of 0 is right here, if we don't know that, and we plug in a 1/2, that means f of 0 we're told is negative 4. F prime of 0 we don't know, but we do know x. X is 1/2. This right here was given to us. If I plug in 1/2, that evaluates to negative 3. And now I just have to solve for this unknown right here. Alright, so I would add 4. So f prime of 0 times 1/2 equals 2. Therefore, if I multiply both sides by 2, it looks like 2 equals f prime of 0. Alright, that would get you, I believe it's probably 2 marks there on the exam. Okay, if it is known that the second derivative is negative 2/3 and the third derivative is 1/3, find the polynomial of third degree. Okay, so now we can build this thing. Let's take this down here for part B. So the polynomial of third degree that would represent this would be f of 0 plus f prime of 0, which we just found is 2 times x, minus f double prime of 0. I'm putting a minus there because I know this is 2/3. That'd be x squared. Don't forget, over 2 factorial. Okay, and then the third derivative is 1/3. That'd be x cubed. Of course, don't forget the 3 factorial. So let's clean this up a tad. The third degree of your polynomial would be negative 4 plus 2x. Those 2's will go away. I'll get minus x squared over 3. and this will become plus x cubed over 6 times 3, which would be 18. There we go. We got a third degree polynomial. Of course, Maclaurin. It's awesome. Okay, so it says the function h has first derivative given by h prime, which is equal to f of 2x. Okay, so let's write that out first. So for part C, h prime of x is going to be equal to f of 2x. So let's script that out here. So h prime of x will be this polynomial with 2x plugged in. Okay, I'm just following exactly what I'd come up with, doing a direct substitution of 2x. Okay, so now let's see what they want us to do. It is known that h of 0 equals 7. Find the third degree polynomial for h about x equals 0. Okay, so check this out. If I want h of x, what do I have to do to h prime of x? I have to integrate it. So I got to integrate this thing. Now I'm going to do something kind of funky. I'm going to put my constant first. So remember my plus c, so this would be minus 4x here. Okay, this right here is 4x, so that would be plus 2x squared. Okay, this term right here would be 4x squared over 3. If I integrated that, I would have minus 4x cubed over 9. And this term right here is, what would that be, 8x cubed over 18, which is equivalent to 4x cubed over 9. Oops. Yeah, 9. Oh, but look at that. I just realized it only wants a third degree polynomial. So we're good right here. Now how do I come up with c? Well, c was given. It says h of 0 is 7. And we got it. Here's h of x. We used integration to find it. 7 minus 4x plus 2x squared minus 4x cubed over 9. Here it is, folks. I'd say I'd give us a nice, if that was the full AP free response question, I'd give us a 9 out of 9 on that one. All right, that is day number 2 with a little bit more on Maclaurin, Taylor, and some free response stuff. All right, see you next time.